Hello, in this video we're going to draw some Lewis structures. So let's say we've got CCl4. We would call that carbon tetrachloride. Now when we look on the periodic table, carbon has 4 valence electrons. Each chlorine has 7 valence electrons, and there are 4 of them. So we would take 4 times 7. That's going to give us a total of 32 valence electrons to work with. From there, we decide what our central atom is. In this case, it would be carbon. We would put our terminal atoms around the carbon, and then we would bond them with a single bond. A single bond contains 2 electrons, so we've drawn 2, 4, 6, 8 electrons so far. That means we've got 24 electrons left to put in our structure. We're going to start adding them to the terminal atoms, and we're going to add them in pairs. So we've got a lone pair that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We've got a total of 32 valence electrons in our structure. Each chlorine has 3 lone pairs of electrons and 1 bonding pair of electrons, so the octet rule is fulfilled. And the carbon in the center has 4 bonding pairs of electrons, which is 8 total electrons, and the carbon is stable. So now let's look at NH3 as an example. When we look at nitrogen, because it's in the 5th group, it's got 5 valence electrons. Hydrogen has 1 valence electron, but we have 3 of them in our structure, so we'll multiply 1 by 3. That's going to give us 8 total valence electrons. Nitrogen will be our central atom. The atom that we have 1 of will be our central atom, and it's typically the one that's the most electronegative. We've got our hydrogens, which we will put around our nitrogen and bond them with a single bond. That gives us 2, 4, 6 electrons. We've got 2 electrons left, but we're not going to put any lone electrons on nitrogen because it's stable with 2 electrons. The lone pair of electrons would go on nitrogen. So we've got 2, 4, 6, 8 electrons in our structure. Each hydrogen is stable with 2 electrons, and nitrogen is stable with 8 valence electrons. Now we'll look at CHO2 with a -1 charge. So carbon has 4 valence electrons. Hydrogen has 1 valence electron. Each oxygen has 6 valence electrons, and there are 2 of them. And the -1 charge means we're gaining an electron. So we've got a total of 18 electrons to work with to make this structure stable. Carbon will be our central atom. We'll put the hydrogen and the 2 oxygens around the carbon. We'll bond each of the terminal atoms to the central atom, and we've got 2, 4, 6 electrons out of the 18, so we've got 12 left. We're not going to put any lone pairs of electrons on hydrogen, but we'll start putting them on oxygen. So 2, 4, 6, 8, 10, 12, and that gives us the 18 electrons that we need in our structure. But if we look, carbon isn't stable yet because it's only got 6 electrons. So we're going to take a lone pair of electrons off of one of our oxygens, make it a bonding pair. We've still got 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. But by moving that lone pair of electrons to make it a bonding pair of electrons, now carbon has 2, 4, 6, 8 electrons. So it's stable along with the hydrogen and the oxygens. Next, let's look at a couple of hypervalent structures. Let's say we've got PCl5. Phosphorus has 5 valence electrons. Each chlorine has 7 valence electrons, and there are 5 of them. So that's going to give us a total of 40 valence electrons. Phosphorus will be our central atom. We'll put our chlorines around the central atom, and we'll bond each chlorine to phosphorus with a single bond. So we've done 2, 4, 6, 8, 10. Out of the 40, that gives us 30 left. So we'll put 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and we've got all of our electrons in our structure. Each chlorine has 8 valence electrons, so they're stable. Phosphorus ends up with 2, 4, 6, 8, 10, but because phosphorus has empty d orbitals, it has the ability to expand its octet and become hypervalent. So that would be our structure. Lastly, let's look at XeF4. Xenon has 8 valence electrons. Each fluorine has 7 valence electrons, and there are 4 of them. So that's going to give us a total of 36 electrons to work with. Xenon will be our central atom. We'll put our 4 fluorines around our central atom, and we'll bond each of those fluorines to our xenon. So we've got 2, 4, 6, 8 electrons so far. That's going to give us, if I can do my math, 28 electrons left. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, but we've got 4 electrons left. Those electrons are going to go on our xenon because it has the ability to be hypervalent. So xenon will end up with 4 bonding pairs of electrons and 2 lone pairs of electrons in order to make a stable structure.